6, 5, 4, 3, 2, 1. And we're live. This is Retraice, segment number 65 for Tuesday, November 29th, 2022, 11 p.m. Eastern, 8 p.m. Pacific. We're going to talk about intelligent agents, agent programs. We're going to talk about the first, most basic agent program in AIMA4e in both pseudocode and Python, but only very briefly, just to get your feet wet. Okay. Oh, geez. I didn't quiet down all of my telephony. I was kind of in a rush, to be honest. Like, I wanted to put this code in front of you. What am I talking about? Let me show you. Got to switch my view over here. Okay. That is the pseudocode. If you're on the YouTube channel, you're looking at it. We are also going to show the Python code right there. Pretty cool, right? We'll get to that, but I'm kind of, again, with my skis. I'm out over my skis getting this all in front of you cleanly and in a way that's constructive. What is Retraice? Retraice is about what's going on out there. It's a podcast. The short answer to that question is computer control. Maybe roughly equivalent to the concept of AI. The long answer is that to the question of what's going on out there is that nature is the first thing, which is not effing around. Artificial intelligence, which is new. Natural intelligence, which is old. Strategic intelligence, which is in between. By strategic intelligence, we always mean spy stuff, counter-espionage, espionage, covert action, that sort of thing. And the last thing that's going on out there is humanity, and that's the best part. But Retraice, this podcast, is for outsiders. But we came to the conclusion that outsiders are not players, and the computer control game is player-oriented, and so now we're learning to play by maybe kind of sort of becoming autodidactic artificial intelligence engineers. Got it? Good. We say it every time. Eventually it'll sink in. All right, we're talking about the table-driven agent. This is page 48 of AIMA4e, Artificial Intelligence, a Modern Approach, the Great White Brick. And what are we doing between now and January 1? Non-inclusive? No. Let's say between now and December 31st inclusive, we're going hard at the math and the code so that when we do a deep dive study of AIMA4e, what did I call it that? I think I did. From January through June inclusive next year, do a 6-month deep dive. We're not going to get hung up on any code or math. This is sort of the first dipping our toes into that project, and we're starting with pseudocode, the first program, pseudocode program, the first agent program, and the first real math of any significance happens. They both happen on page 48, and they're linked together, obviously. But today we're only going to talk about the code. So what is it? This is a table-driven agent. There are different kinds of agents: table-driven, reflex, model-based, goal-based, utility-based, learning-based, all kinds of different agents. And we're talking about agents that are basically computer-based hardware and computer programs together. But you should think of intelligent agents as being a more broad, abstract category than that. They don't have to be the architecture doesn't have to be a computer plus a computer program. We could probably find something that is essentially mathematically equivalent to a table-driven artificial intelligence agent in nature. But I'm not qualified to find one for you right now. What do I look like? Somebody who can do that? No, not me. I can barely get a PDF with highlights happening in front of you. But watch this. Barely still means I did it. Check it out. Clicky click, wrong click. Click the wrong click. All right, clicky click again. There we go. Look at that. You're looking at pseudocode from page 48, although this is not from the book. Thankfully, the AIMA guys put just a standalone PDF on their website, on the website for the book that has all the pseudocode in it. And just the pseudocode, so I don't have to worry about copyright infringement. If I put the book in front of you, even with all my markups on it and stuff, I still worry that they're going to come after me, and YouTube's algorithm is going to classify me as doing untoward things with that there book. All right, so that's the pseudocode. I'll explain it in a second. And then if we switch over to the Python, the GitHub repository, this is the Python code. This is the section of agents4e.py that has the relevant code. That's the implementation of the table-driven agent. Okay. I know it sometimes sounds like I say Asian when I say agent, but I'm almost always saying agent, not Asian. Let's go through this one line at a time. I don't know how to make this easy. Okay, let's just talk. Let's just relax here for a second. I don't know how to. I have never taught this to anyone, and I barely understand it myself. That's where I'm at. But I didn't just like throw this together today. Like I've spent time thinking about this program. I'm going to be able to walk you through it sort of clumsily. But you know, how you in particular are going to think about this program is going to change over time. And you're probably, if you're totally new to this, this is going to be difficult. Don't worry about that. I'm not going to put this in front of you once with one kind of explanation that was my first go at it and expect that you absorbed it all and blah, blah, blah. We're going to come back to this. The reason we're doing this now as part of our math code blitz during late November and all of December is so that we get familiar with what's going to challenge us. What in the body of the book? It's not going to be the English. It's going to be this pseudocode, and it's going to be the math that we'll deal with maybe tomorrow or the next day, you know, depending on where we want to go with this, or whether I want to do a second day on the table-driven agent. The point is, try and get familiar. Okay, that's the biggest problem with mathematics. People just don't know what symbols mean. They don't know what the notation is communicating. They don't know how things are abbreviated and elided and arranged. And then there's so much repeated use of different things that are different in different contexts in both math and code, but especially math. Today we're dealing with code. Just think of yourself as exploring a new part of the woods, or watching a sport for the first time, or playing with a gadget, or watching somebody cook. These things where you're not methodically taking down or trying to commit to memory every little nuance. Okay, this is a very human back and forth we're going to do with the black and white, mostly black and white symbols that are going to be in front of you. Although, if hopefully you can see color, most people can, but a lot of people can't. But if you can see color, we're going to try and use the color to make it easier to separate all the black and white, because that's one of the hardest things to do in black and white text. If you don't have syntax highlighting in your code, get it, stop what you're doing and get it. But most programs have it now. They didn't for a long time. And if you are looking at the black and white characters of this pseudocode, you're going to want to mark it up. Mine's marked up crazy. Look, I'm going to show you my book. Actually, I didn't use a lot of color, but mine's marked up like crazy. I'm going to show it to you quickly so I don't get in trouble. Look at this. This is my 48 and 49. Look at that. It's glorious. And this is where up top is where the pseudocode for the table-driven agent is. But we're going to work from a PDF because blah, blah, blah. I said that. Okay, let's switch over. It's clicky, clicky. There we go. Oh, you can see my hand. Thumbs up. Okay, so start with line 1, and you're going to see my little temporary highlights here, and then I might make some permanent highlights to do even more. There we go. So this is line 1. So what this is saying is in pseudocode, and pseudocode again is written in a way so that you can understand how the program works, how it's structured, but you can actually write it in a specific programming language, whether or not or independently of the way that it's structured. So basically, pseudocode is designed to write down a computer program so that it can be specifically written down in many different types of languages. Any languages that support the control structures and other elements of the computer program represented in the pseudocode. Okay, so this is now here's a complicated thing or a confusing thing. Actually, let's get away from this. I don't want you just staring at text. You're going to hear the word function, and I'm not going to go into every little thing in this much detail. But when we talk about an agent function in the context of AIMA, that is not what we're talking about when you see the word function in a programming language, either in the pseudocode or in the Python. An agent function is actually in the pseudocode is the table, and in this context. So this function is a programming function, and everything indented falls under what we're calling this function. But the agent function is the table. Got it? Is that confusing? Good. Okay, great. So this is a computer program function. The name of it is table-driven agent, and in the parentheses we see it takes in what does it take? A percept. This is the argument or the input that gets sent to the program for processing, and it returns an action. And down here we see the action. Okay. So what happens? You're going to type a on a command line. I know you can't picture that right now, but I'm not ready to put that in front of you. We'll do that tomorrow probably. And you're going to type table-driven agent, and then in parentheses you're going to give it whatever we decide is a percept. Okay, so let's just say, I don't know, red. Okay, let's say red is going to be our percept. Then what the function is going to do, and this is the computer function, not the agent function. This is the pseudocode function. This is so confusing. Okay, so first it's going to have a sequence, a data structure already. It's going to declare it, or it's going to initiate a data structure called percepts, and then it's going to have what we provided separately, a table, which is going to be another data structure that has all percept sequences and their associated actions specified by us. That's the agent function. This is the simplest agent function you can do. These are two things. So they're both labeled as persistence here. And we should just think of these things as data in memory. Okay, so I know this is unfamiliar. Just keep going with me. Okay, so then what the function is going to do is going to take the percept, the red that we gave to the program before we started running it, and is now is in memory and is known to the program. It's going to take that percept red and it's going to append it to the end of that data structure percepts. Okay, so it's initially empty. Now it's going to have just red in it, and then it's going to assign to the variable action the result of a lookup function on the percept, taking the percepts, which now has our word red in it, and it's going to look up what do I do, or it's going to look up the associated pair value in the data structure table I know this is hard to follow. It's going to look it up in the table to find the action, and then it's going to assign that action to this variable action, and then the last thing the function does is return the action. Now, it's not going to, okay, let's stop looking at this right here. It's not going to actually, this program is not going to move its arm, or like if it sees red, it's not going to go thumbs up. Okay, this is just a program. If we're talking about an agent architecture, then we're talking about hardware. Again, I'm using the lingo of AIMA4e. This is you can squish these words any way you want, but the way that they use them, agent architecture is hardware plus software. The software we talk about, and most of the book is about agent software, agent programs, is what we're looking at when we look at this AIMA code, this AIMA pseudocode. Okay, so what does it mean? How do these words written in black and white, how do they return an action? They don't return an actual action. They return whatever we had in our table of percept sequences and actions associated with them. So if we specified in our table that if the agent program, or if the agent perceives red, that it should, give a thumb, return thumbs up, like the words thumbs up, not like an actual thumb, but like the words thumbs up, then when we run that program, we give it the argument red, what's going to come back on the command line is going to be thumbs up. This is how we'll do it tomorrow, because I know this is hard to imagine. That's all it does. If you put this if you write, okay, so let's look at the Python version. Okay, so this is the Python version of what we just described. This is an actual programming language that is actually capable of controlling your computer if you install Python and then you save this text as a .py file, and then you call it using the Python program. Okay, so we're defining a function called table-driven agent program, and it takes a table. Remember, we said the thing that we have to provide is the table here. We have to provide that separately before we run the program, or nothing's going to happen. Over here in AIMA code, we're seeing that it's taking that's what this program does, is it takes our table as an argument. So let's read their comments. Okay, the stuff in blue with the quotes at the beginning and the end. First, they're saying figures 2.7 is what this corresponds to. We see that over in our PDF. Figure 2.7 is the one we're working on. Okay, so here are the comments. This agent selects an action based on the percept sequence. It is practical only for tiny domains. To customize it, provide as table a dictionary of all percept sequence action pairs. Provide as table. What does that mean? Can you see my highlights if I do that? Yeah, provide as table. It means we should create a dictionary in Python. Dictionary is a kind of data structure in Python, in lots of programming languages. A dictionary that has percept sequences. So in our first case, it would just be the word red, and actions associated with them. It's a little colon and then action. And our action would be thumbs up, okay? So you got to call that table you've got to like name that table when you call the function. I know if you've never done any programming, this is going to be hard to follow, but don't worry, we'll get there. And then if you run this, if you call this function and you give it this table, our table argument, which is the agent function in our confusing language, then it's going to return the second part. It's going to detect not this part. Okay, so the first part that we've established here is that just our table-driven program has the table in it, and then it also next is going to we're not able to return any value, any thumbs up yet because we're not there. So now we're at percepts. So this is the empty persistent variable or memory object that we saw. Okay, so when you see percepts here, you should be seeing in your mind percepts here. It starts out empty, and now within the table-driven agent program that has the table, we're going to define another function that's our agent program. Remember, agent function and agent program are different. So the agent program takes a percept. Okay, now we haven't provided the percept, and I think so. This is indented. Indentation is significant in Python. I don't remember exactly what I have to type to call this program. I think maybe it's like table-driven agent dot. Is the program a method? Anyway, somehow we're going to have to get the word read to this second function, which is within table-driven agent program, and so that it can do something with it. What does it do with it? It uses the append method to take the percept and put it on the end of percepts, this thing here. And then the next step is it sets the variable action to the result of using the get method on table to find the tuple or the pair, the thing that goes with the percepts, which in our case is going to be the words thumbs up. And then action, that variable will be set to thumbs up. And then when it returns action, it'll return the text thumbs up. Okay, and so I'll be able to more clearly demonstrate this tomorrow when I'm ready to kind of demonstrate it on screen. But that's sort of the basic gist of it. Okay, so it's input and output. Going back to the pseudocode, really the only thing I highlighted here, like persistently highlighted, is the input, which is a percept. Actually, you know what? Let's highlight table as well, because table is an input as well. But that's an input to in the Python implementation. It's an input to the table-driven agent program function, and then I just don't remember how I get that. When am I asked for the red percept? Let's say if we're going to use red, but anyway, that'll be very easy to work out, before tomorrow. Okay, a percept goes in. We also provided a table in advance, and the thing we're going to get back is whatever action is associated with that percept. Now, another thing to remember, let's get the text off screen. Another thing to remember is there's a difference between the agent program, which is everything in the pseudocode there, and the agent function, which is the part inside, in our case, it's the table that maps percept sequences to actions. The agent program can only, the only thing it can interact with is the current percept or the next percept, whereas the agent function, the table that we provided in there, can look at the current one as appended to the last 6 or the last 10 or the last 100. And so we can say if our percept is the word red, we want to return the phrase thumbs up. But if our percept is if our percept sequence is the last 4 percepts and they were red, red, green, red, 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 green, red. Oh, no, we want thumbs down. Red, red, green, red is not a thumbs up. That's not a thumbs up. That's a thumbs down. Okay, we can specify all that in our table. But in this case, we're keeping it very simple, and that's within the function. The agent program can stay the same when we change out different tables, i.e. different agent functions. I don't know how easy it is going to be to listen and to keep using the word function in 2 different senses, but you just have to remember, if I say function, I'm talking, if I say it with no modifying word, I'm talking, I'm almost certainly going to be talking about the program, the function, the Python, function in the Python programming language, or a function in the pseudocode language. But if I say agent function, no, that's a technical AI word. That's from AIMA. That's not a programming word. Agent function is an AI word for term. So yeah, but there will be other things like that that'll just take some getting used to. So that's it. The basic thing to remember, I'm going to put it up one more time or get used to, is input, processing, and output. So our input is the percept and the table, sort of separately from the specific call of the function that we're going to give the specific percept. And then the output is just an action. But if you're just working with computer programs, the output's in the most simple way is just going to be some text on the screen, unless you've arranged it to interact with some graphics, or you've connected it outside the computer to effectors and actuators, and you're just going to be an actual thumbs up. If we want to give an actual thumbs up, we got to go all the way to the end of AIMA4e and start talking about robotics, right? But right now we're just talking about the brains of the operation, and most of the book is the brains of the operation. So we're just going to stay in text because we're not really concerned with making the robot hand do this. We really want to make sure that our brain is thinking what we want it to think and behave, and producing behavior in the form of text, in this case, that we like. All right, I'm going to leave it there. There's so much more to say about this whole... I always have more to say. I don't need to finish that sentence. All right. References will be in the PDF notes at retraice.com, retraice.com. Also always reachable by the YouTube video or the podcast RSS feed entry that you used to download this segment. This is segment number 65. We'll be back again tomorrow, 11 p.m., same time, 8 p.m. Pacific. And I think that's it. That's definitely it. Signing off.